Welcome to my stream, where knowledge reigns supreme. Calm and collected.
Fixerbot says,
Welcome. Stream starts in 5 minutes.
Gonna teach you something new. Learning, hacking, exploring. There's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unravel the secrets, unlock the code. No limits, no boundaries, so knowledge will explode. Welcome to my stream, where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow. In this stream of knowledge, together we'll grow.
T minus 4 minutes.
Welcome to my stream, where knowledge reigns supreme. Calm and collected. I'm about to go live, you know what I mean. Got high expectations, gonna teach you something new. Learning, hacking, exploring. There's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unravel the secrets, unlock the code. No limits, no boundaries, so knowledge will explode. Welcome to my stream, where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow. In this stream of knowledge, together we'll grow. Welcome to my stream, where knowledge reigns supreme. Calm and collected. I'm about to go live.
Stream about to start. 1 minute left.
Expectations, gonna teach you something new. Learning, hacking, exploring. There's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unravel the secrets, unlock the code. No limits, no boundaries, so knowledge will explode. Welcome to my stream, where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow. In this stream of knowledge, together we'll grow.
Oh, sweaty today. It's really warm here. So let's see, what is it? It's 28 degrees. Oh, it's kind of warm for here anyway. Very sunny too. So I found some of my old notes there, and I've been like transferring bits of it. So I was thinking, what was I doing yesterday? So I've been listening to podcasts all day while working. So my brain is like, it feels like it was 2 years since yesterday, that kind of thing, you know? Yeah, so we have this room. Where are the rooms? Well, they should still be up. Well, let's open TryHackMe then. So, not this one. That's kind of why I think it's important. Is it that it's too bright so I can't see the icon? I did restart the computer actually, which is like not common. Oh, here it is. So let's actually close this tab. Now let's go to this one so we don't have several up. I have enough tabs anyway. So I just got some sandwiches and one of this reciprocity kind of things. I needed something a bit sweet, so it's blueberry jam. So I'm a bit late because I went shopping, food and stuff. So they have this secondhand clothes store. I love going to secondhand clothes store. You always find something fun. Just by the store, by the food store. Yeah, and I didn't bike today actually because, yeah, hard to shop with a bike. So let's see. Right, we were looking into this. Now I remember. So we were going to override this, and we were doing a bit of ChatGPT. We'll see if it remembers that we were talking to it. Yeah. So since I restarted and closed everything, let's see, how much should we go back? I don't know if we need to go back anything, right? So we did one here. We just write a string longer than the buffer. We also tested that we would override it with the null termination of the string too. So yeah, so I just sat down, a bit tired then, but let's start Kelly, and I'll continue eating. This is at least kind of stream friendly, right? This was really good actually. It was a perfect thing right now. I usually think these are too sweet. I guess it's that I'm really hungry that makes it okay. And also it's like blueberry, it's not strawberry or anything. Right, then start my phone. Start everything a bit quickly here. So let's see, can I switch screens? No, it doesn't really start it. Since I had the app up, I will have to realize that I restarted stuff. There. Now it's doing its 5-second ad.
Jonas just says,
click something.
best viewers on web
Oh,
link.
okay. Well, no one clicks the link. Let's see here. Maybe we should start with that actually. Get rid of those. I've said it like 4 streams, right? When we had those that I'm going to, but I've never had time to do it. It's just a short bit of C#, hopefully. Best viewers on, and then they usually have some different URLs, so the best viewers on is the best thing to go on, I guess. So I'm trying to find myself in the Twitch app. They change it. So what do I click now? My channel there. And then I go to chat. I'm going to just remove that message. So, delete message. There. I'll just finish this. I have actually 3 sandwiches too. We'll see if I can eat them all. But I'm very hungry, so... since it was kind of warm, you know, it was actually warm at work too. I got hungry. Maybe it had less sugar. So, my eyes are really going, you know. Well, I guess it's not a tiny bit of sugar in those. Yeah, so I bought clothes. Let's see, this was like a one, and then we have like for when I'm biking. Where's somewhere? Where on earth is the up and down? There. So this is kind of nice, very thin. Nice. Oh, a lot more. Yeah. So I'll have to put all that in the laundry. And it was all like so it's very cheap. The most expensive ones are $5, and the cheapest, I don't know, $2. So, this is TryHackMe, so let's start the VPN and stuff. I think it's still waking up. Not. I guess it's just when you click back and forth. Hi!
Hey!
Welcome in! So, I'm just starting everything here. So we have a lot of things to do. Also, since I had to change the VPN because they made changes, TryHackMe. I'll have to change all my scripts and stuff with a new IP too. So that's not very fun to do on stream, is it? We're going to do more about buffer overflows. So this room had the link here to this, but we already have this installed. But I thought we could read this. Since I am actually eating a bit, let's actually TTS this, right? I can finish without feeling so hard in a hurry. So I'll just do bits. Oh, did I click something else?
See the releases page for
Oh,
downloads.
so.
The current Git master branch is 5.9.3, next will be 5.9.4. Since R2-5.6.0 all the patch releases are ABI stable. Odd patch versions are used in Git builds only, releases use even numbers. No need to recompile the plugins, bindings, or tools if the major and minor version are the same. Description: R2 is a complete rewrite of RAID array. It provides a set of libraries, tools, and plugins to ease reverse engineering tasks. Distributed mostly under LGPL-v3, each plugin can have different licenses, CR2L, RASM2L. The RAID array project started as a simple command line hexadecimal editor focused on forensics. Today, R2 is a featureful low-level command line tool with support for scripting with the embedded JavaScript interpreter or via R2 pipe. R2 can edit files on local hard drives, view kernel memory, and debug programs locally or via remote GDB/Windbridge servers. R2's wide architecture support allows you to analyze, emulate, debug, modify, and disassemble any binary.
And so far, I had only used it to get strings out of an executable, I think. So. So, you can edit files, view kernel memory, debug programs locally, or via remote GDB, WinDBG servers. Wide architecture. Analyze, emulate, debug, modify, disassemble any binary. So I'm thinking it's Windows there, right, too? Now let's look at the image. Okay, it was not an image. But I wanted to see the image. Let's look at the image too. It looked interesting. So this looks much prettier than this horrible one we had in here. I don't remember the name, so... It's definitely in there. Let's find it. Oh, it's right here. Immunity debugger. That looked horrible, right? This was pretty cute. And not as tiny text, I'm assuming, since it looks kind of DOS/terminal style. So we don't need to install it, it's pre-installed in Kali. But we could have just run an SSH. Oh, what am I saying? SH. Install script. And Windows, there are pre-compiled builds. Or you can compile it yourselves there too. Okay. So there are plugins and stuff.
R2 can be installed from Git or via pip using R2env. Run sys/install.sh for the default ACR plus make plus symlink installation. Meson/ninja, muon/samu also works, and make builds are supported. Windows builds require Meson and MSVC or Mingo as compilers. To uninstall the current build of R2,
Daily
run make
Grind Boost
uninstall.
says, why are you trying to
To
learn how to
uninstall
hack?
all the system installations of R2, do sudo make purge.
Ah, to get
Popular
a good
plugins.
job. A fun
Using
one.
the R2 PM tool, you can browse and install many plugins and tools that
because
use
it's fun.
RAID Array 2. Easel Solve, the symbolic execution plugin, based on Easel and Z3. IADO, the official Qt graphical interface. Keystone assembler instructions using the Keystone library. R2AI run a language model in localhost with Llama inside R2.
So, let's
R2 deck.
Just one more sandwich, and I'm still kind of hungry, so I thought I might not be able to eat all three.
Daily Grind Boost says, like a cybersecurity job?
Yeah, cybersecurity job. So,
VR Mechatronics says, Hi again.
welcome back, VR. So, popular plugins. So it seemed to have a lot of things there. But most of them I don't understand what it is, because I need to learn more about this area. A lot more. So... R2 and a file name here. Open file in read only, and AAA, analyze the program. R2 capital A, list all functions. So this is listing the functions. And there are alternatives. This was more confusing than helpful, really. And the one I used, well, let's hop over here to the notes. So I did the A one, and then I did IC, and here we have the help file too, which is better, right? So A, analyze all referenced code. Run AAA. Okay, now I get this. So when you type AAA, when you're at this prompt here, then it's the same as doing R2-A from the start, right? Okie dokie. But what is this? An AFL. Now, there are like commands too. I should have a command list here, right? We need a list of those too. So we can use this. So px32 print 32 byte text on current block as main is seek to main using flag name. F foo filter flags matching foo. So this is a grep, internal grep. ISS list sections and symbols. And this is probably some other command then. PDF, AGF, disassembly and ASCII function graph. OO plus, hello. Reopen in read write and write a string. Reopen in read write and write a string. Yeah, so I don't know what this means yet. Interactive filter in all command help. Q for quit. Always good to know how to quit stuff, right? Many plugins are included in R2 by default, but you can extend capabilities using the R2PM package manager. Okay. Resources. Official book. Book ready.r. Oh, that's funny URL, right? So here we have a book about this program. One tool we can read for ever, right? Community engagement, all those guidelines. So same as doesn't help if you don't know what this thing means, right? Standard way to run R2. W is also right then. Debug. So we can start it with debug mode here. Okay, so I'm thinking, of course, apply to this executable that we have here, that we didn't actually look at the tool that's mentioned in the room. And we probably should, right? Not that the one we tried start using last time was wrong or anything. I'm full. YouTube talks from R2Con. Conference on this tool, so it has its own conference. Well. So, I guess we should get started. Architectures. Game Boy is like everything here. Not everything. Oh, sorry. Oh. Yeah, so let's have this in mind when we continue looking at it, that we could use this tool too. We opened this tab yesterday. So the difference from the previous one, where we just was supposed to override at all without outside the buffer here, that now we have a pointer here, right? Knowing that it's not text. So we have an int new pointer, and it points to normal, and we want it to point to special. So I was thinking that we need the address of special here, right? That's what I'm thinking, because I'm assuming that the names will disappear. Maybe they will be kept. Yeah, it would be nice to look at the memory of this and see. So why not try this tool, right? And we have the help nicely colored from Obsidian here. So what if I do like search for memory? That's nothing there. I'm just reading a bit on there. I'm thinking we'll just run it and see, cause I don't remember much from. We used another one. Where is it? Like, yeah, this is where I put it. So we run GB, and we looked at stuff, and we found how to list stuff. Info functions there. We've just found this. I'm curious where I read that, really. Yeah. So it was for actually ChatGPT. Print the address of a specific function is P then. So we can continue looking at this. Then we have the problem of inputting stuff, right? To there. Because, you know, we don't want to type the ASCII digits. That's not what we want to do. We want to have actual numbers. So I'll have to realize how to do that too. And this room, actually, first I thought, well, this is seems like a basic, but then it's like this question. This was very simple, the before. Overriding a variable. This is very simple.
Spring says, Fix It
Hi.
42 Wave.
So this is very simple, but the next one. So I guess we should try first with the name of it. You know, we could try that and see if it works, because it might. I didn't try it, so why not? You know. If it still has some kind of labels there. I didn't think it would, so. But I don't know what to do. Let's test stuff. So, first of all, we did connect SSH to it, right? First of all, start it, right? And we had this information. Actually moving this over here. And let's. So I'm feeling after lunch now. This is why I'm supposed to bike to work, right? So I don't get tired afterwards. Because I'm really tired. Though it's also I should have slept more. We need the IP. 25 seconds. Oh, looking to do. Well, let's go back here and start typing SSH at least, right? User 1 will be the same. So 3, 2, 1. It's always kind of cute that it's 3, 2, 1 and I didn't get an IP. Come on. Well, I was thinking it was slow, but it's usually not that slow, right? Well, I could type. 188. 181, 246. There, and then we had the very nice password of user 1 password. So user 1 password, right? And let's look here. We had the overflow 1. We're still nowhere 2, so two. And there we have the code. So the special function that was supposed to run instead of the normal one. And then there's another one. Why is this there? Yeah. So when we run it, right, I have no shortcuts in my notes. Let's actually play with these, because I've been asking people like, do you have a suggestion for this? And in chat, and people don't have. So now I actually found it in those old notes I was looking at. Yeah, shell types. And I also had. No? I'm so sorry. So I have it under Linux, and then I have shell shortcuts. And these, Control E, go to the end of the line, Control A. Let's just see if they work here. So they work on my machine, and then we have K and U for delete all characters after the cursor, delete all before. So before is kind of useful, right? You start typing something, you arrow to the right, and you realize, oh, I have to do another thing first. And you don't want to mess up your history with stuff, right? So then it can be kind of nice. So if I want to delete all of this after the cursor, I do just Control K. And not being in there, because it kind of messed it up. It made a link of it in Obsidian, apparently. So if I Control K here now, we delete it. So if we type a lot of random stuff. Oh, I heard something, but I didn't hear what it said. I'm sorry. I'll hop over to there. So let's see, we have Control K and Control U here, and then I just added these to have a more complete list, and then the Control R was actually in the shell tips one, so I moved it. So we have all the things in the same place. Just get rid of that selection. So if we want to delete everything now before the cursor, just Control U. So let's say I was typing something from another old thing, and I'm like, oh no, I mistyped or whatever, you know. Like starting, let's do right. We're on the box, so we don't have any history. Yeah, let's continue instead now. So this is nice. I'll try to remember, especially the Control U is useful. Because it happens a lot that I paste the wrong thing. I could like paste let's say a copy fail. I copy something tiny and I had a long like list of stuff, and it's all there, and you don't want to like, you could of course like arrow up and you get a shorter line to delete, but Control U and it's all just gone, right? So let's actually do a paste test here. So if I copy all of this, we paste it here. I'm actually having to hop over to this, and right, this one didn't do it very nicely because it's just, anyway, Control U. So if you paste it like that in Kali, you usually don't get that. Let's open a new tab and paste it here. So if I paste here, it looks like this, and I'm like, oh my god, I can Control U several times. Okay, so it deletes one line. That's much better than backspacing it all. All the tricks, you know? And I didn't even think of Googling it, you know? And also the Control A and Control E, so we can Control A and E, we can hop to the start and the end, and then we can go to the start of it and do Control K and delete it all if we wanted to. Or rather, we could go to the middle of it and do Control K, and then we could do Control U. Had to play with it to learn it, right? So these could be useful to speed up what you're doing. Right here we need more comments. This is what we did yesterday. Alright, this is what we did yesterday. What's this then? Did I just paste it in two places? It's not exactly the same anyway. And here's the VM debugging. So I'll have to finish that too. Yeah, it's time to actually do something. So I am extremely tired. It's already 14:23. How did that happen, right? Water. Yeah, this bottle is horrible. Because if I drink here, it'll runs all this way. I'll have to throw it out. And even did that, so I got water on myself instead. Well done. We're SSH'd. We can try. Let's do R2. It's here. So let's see what the file. Oh, what was the file name? So if we do R2, justice. We have to test all the things now, right? So, find expanded ACE keys in memory with CA. Well, I don't know what it is, but let's do that. So, let's see if we have help. No. Head 7 file. So we need some kind of help here, because this is not what's in when we're actually running the program, right? I only know the IC that we didn't do the A now, so I'm thinking IC might not work, right? Yeah, it showed the strings, so we have the strings here. So how would I show like the functions? I think it was already there in what we read, right? So this is commands, and we don't want to do commands now. We want to have like in there in its prompt. Let's close that one. Here is the book. So if we just, this is history of it. What's tool chain? User interface. So many different over the years. This is a GUI for it called Yaito. Okay, so that's where that screenshot came from. Web UI too. Installation. First steps. Yeah, so command line and help that we already have. But I want its command line, not the normal command syntax. Here we go. Come on, give us some list. Okay. That's not really helpful either. Let's just read it from the start. In a single line, we can describe the syntax of a reader to command. Let's see what debugger session is. Yeah. Here we can step 3 steps. So yesterday I looked at a very cool site. Let's see if I can find it. This is definitely not it. Yeah, it must be forward. So many things here. Yeah, we opened a lot of things on assembler yesterday. I actually created an account. I thought I had one on this one. And I did 2 for testing. Yeah, these are more of the assembly links. Tutor. These, yeah. So we have this cool site, and this was just for installing stuff to make it actually another VM, right? Another Windows VM. So I was kind of thinking to use the same, but these are free education. So from the start page, could we reach that here? Hopefully, right? You can just go to classes, and there were a lot of cool classes here. So I think I clicked this one. But this is what it says my, because in this it says click this, so that's why these popped up too. I want to do like show all, but I guess it's like messed up. So we're supposed to, like, before you start the course, you're supposed to set it up. A VM. So we'll have to do this. But all courses, I want to list all of them. Course. Nah. So, learning paths? No. I want to see all the old ones. Discover new, I guess. Yeah, here's the list. So, there are very cool courses there. Low level stuff. So we have debugging stuff, firmware tech and defense, reverse engineering stuff, hardware SPI analysis, C family vulnerabilities, UEFI, kernel internals, cool stuff. But it's not like you read all of these in one day. TPM. Risk assembly. Yeah. So, we'll have to do this too. And it is like open in all the ways. So you can use it on your own course if you want to even. Meaning we should be allowed to stream this with no problem at all, right? Not even having to ask. So I read a bit about his thoughts on this, right? So this was a very cool thing. And I got this link from another cool link that it was actually what I was going for. See if we can find that. No, this is something else. That was from... I checked into the Black Hacker stream afterwards, and she... Oh yeah, this is the honeypot. So I got this tip about this honeypot too. So we'll have to look at this. Close this. Sorry for not being very like active stream, but I have to also reduce the number of tabs a tiny bit there, I think. Yeah, so I was checking if there was like CSS stuff there for responsiveness, and there seemed to be something. We can look at that later. Yeah, and we found this, or someone in chat yesterday gave me this as my tutor. So this seems very basic, but that's great. It's not a lot of lessons. Sockets. So we've just done sockets in C, so file handling calculator. This could be a great repetition / start, right? But the file, or rather the link, I googled while here. What's this? Oh, just random googling too. So now let's actually find this. There's a link on the video from there, and I actually got the tip from him. So that's cool. Yeah, and I tested too here. But this is actually no, this is not that side. I was thinking PicoCDF. Right, now I remember. It's PicoCDF's. Here it is. The primer of PicoCDF is very cool. So if you look at this, you start looking. I was thinking, okay, this is how the PicoCDF works, right? Sorry for having the window open. The planes are kind of noisy. So, and then I was like, okay. And then it starts like, oh, but this is, now we're getting facts here. This is learning. And then it continues. And when you look at the side here, it's programming in Python. So it teaches web exploits, cryptography, network, database, and what we were going for, you know, is the binary bit here. So I'm thinking that maybe we should actually read this. But this is where I found the link to this other site. This one. That's where I found it. It was here at the bottom for its general links. There's also the assembly here, as you could see. Virtual machines. Maybe they even have the solution for my VM problem. Nest virtualization. Oh, it doesn't want to do VSL2 on my VMware Windows 10 machine. Or rather, now it doesn't complain anymore. I managed to get rid of. It's actually starting, but it's getting a like odd error that's hard to find information on it because it's like no error. No specifics, just general error. Here, yeah, the tools. Somewhere here, I found the link. So I'm thinking these will probably have tool suggestions. Let's just quickly scroll here. Memory. They say how the memory looks. And then they mentioned GDP. Yeah, I saw that. So we tried stuff with GDP yesterday. But I don't really know it. So learning about it here, this would be perfect. So maybe I should just like check this. Or rather, we could just scroll through it too. So they started with just this. They run. We did this yesterday. They click R. R instead of run will do the same. Okay. So R is run. Q quit. We realized it was quit after me testing. Try and help. It wasn't a help. So open again with another one. Executable. B vol. So let's actually read what it says about B vol because we used something like this yesterday. Before we running using, we want to stop at the beginning of the function vol 0 or like while. That's so parenthesis. Am I like tired or something? Yeah. To do this, you can set a breakpoint at vol. Setting a break must simply means that so by running break vol or b vol. So I think we did break yesterday. We'll set a set a breakpoint, simply. The address you see might be different. That is okay. Okay. What does it mean, breakpoint? One at. Do you remember? Right, so we could actually find the functions address by doing this. But we still would have to type it if we were to do this way and just input it. That's what I don't know. So when we run it and we need to input something into this overflowing buffer that's actually an address or something to point it to the other function. So here's an easy way to find. I'm assuming we can remove the breakpoint, but I'm also assuming that there's an actual way to do this without having to set a breakpoint. The first breakpoint was set, establish address, which is the same as address. An address is a number in this case, so zeros at the left cause no effect. Note that in other cases, zeros at the left have an effect. When what we're reading is not interpreted as a number. Then they're talking about the registers. So we can print the value of this register. I could read it. Let's actually do this. So I need a quick bathroom break. And I'll check in with my kids. And I'm thinking, yeah, let's TTS the bit about GDP. And it will read all of it. So let's stop before all of this. And I'll hopefully be
11.4.1 GDB assembly and machine code. In the web's hell, GDB is already installed, so you can run gdb/vuln1. You should see something like this. New GDB, Ubuntu 8.1-0 Ubuntu 3, 8.1.0.20180409 Git. Copyright, C, 2018 Free Software Foundation Incorporated. License GPL v3+, GNU GPL version 3 or later HTTP URL. This is free software, you are free to change and redistribute it. There is no warranty, to the extent permitted by law. Type show copying. And show warranty for details. This GDB was configured as x86_64 Linux new. Type show configuration for configuration details. For bug reporting instructions, please see HTTP URL. Find the GDB manual and other documentation resources online at HTTP URL. For help, type help. Type apropos word to search for commands related to word. Reading symbols from vuln1, no debugging symbols found, done. GDB. Now, input run and press enter. Remember to press enter after using a command. The program vuln1 will be executed, so you can enter any string and it will print it back, as it normally does the program vuln1. You should see something like this if the string you input is hello picoctf. GDB, run. Starting program, /vuln1. Input a string and it will be printed back. Hello picoctf. Hello picoctf. Inferior 1, process 95,000, exited normally. GDB. If you input R instead of run, it will do the same because R is the GDB abbreviation for run. If you do the experiment you should see the same. GDB, R. Starting program, /vuln1. Input a string and it will be printed back. Hello picoctf. Hello picoctf. Inferior 1, process 95,000, exited normally. GDB. To exit from GDB, you can input quit and press enter. Also, you could input only Q and it will quit too. In several GDB commands, you can also input the first character of the command, and GDB will understand. Now, open GDB again to debug vuln1 with the same command we used previously. GDB/vuln1. But now, before running it using run, we want to stop at the beginning of the function vuln. To do this, you can set a breakpoint at vuln. Setting a breakpoint, simply means that the execution of the program will pause in the instruction you set the breakpoint. By running break vuln or bvuln, a breakpoint will be set at the beginning of vuln. We will see this. GDB, bvuln. Breakpoint 1 at 0x4005 CE. The addresses you see might be different, that is okay. What does it mean breakpoint 1 at 0x4005 CE? Do you remember that there is a segment of the memory in which the machine code is placed? In the memory address 0x4005 CE the machine code of vuln begins. Input R to start the execution of the program and you will see GDB, R. Starting program, /home/Samuel/desktop/problem/vuln1. Breakpoint 1, 0x00040005 CE in vuln. GDB. Breakpoint 1, 0x00040005 CE in vuln, means that the first breakpoint we have set, was established at address 0x00040005 CE, which is the same address as 0x4005 CE, an address is a number in this case, so zeros at the left cause no effect. Note that in other cases, zeros at the left can have an effect if what we are reading is not being interpreted as a number. Processor registers. A program is made up of several instructions that are executed sequentially. The processor of the computer has an integrated and very small memory different from RAM, called the registers. A processor only has a few registers. Each register can hold only 8 bytes in a 64-bit processor, and 4 bytes in a 32-bit processor. A 32-bit program can run on a 64-bit processor, but 64-bit program cannot run on a 32-bit processor. One of the registers is called the instruction pointer, abbreviated as IP, that keeps track of the part of the program that is currently being executed. In a 64-bit program, we can print the value of this register in GDB using $rip. GDB, $rip. 0x4005 CE vuln plus 4, 0x80C48348. GDB. Note that the first part of the line shown is 0x4005 CE, this is exactly where the breakpoint was placed, so the IP naturally has that value because we made the program pause there. Then we have vuln plus 4, do you remember we said that by setting a breakpoint at...
Process register. A program is made of several instructions. Only has a few register. Which can need 8 bytes in a 64-bit. 4 bytes. This is like so. Kind of a whole 64 bits in 64 bits. So 8 bytes and 64 bits. 4 bytes and 32 bits. One of the registers is called a instruction pointer, abbreviated IP, that keeps track of the part of the program that is currently being executed. In a 64-bit program, we can print the value of the register in GDB using X. Okay, so we need to make a bit of notes on this program, right? So I haven't so far. Let's do it. Because this is a very good tool. It doesn't fit in Linux. Where will we put it? Should we put it... I'm kind of thinking we might add something here to our ASM buffer overflow and add like debug, right? It's all connected and it's a mess looking for something and it's in the wrong place. Decompile. Yeah, so a lot of things are connected, you know. Programming. So, yeah, I'm thinking this is where it fits the best. And we don't need to make a special one, but it's low-level debugging. It's not like debugging your Python program or C program. that I mean using these tools, right? Let's change it. Let's say also like debug. It won't fit anyway, so come on. Not that I care a lot, but we couldn't see the text anymore. There, now it's back. It's a bit buggy, Obsidian. It's like it's not. It's always being developed. It looks like that. So we want to put a new note for GDB, and let's take the opportunity. Let's actually first make sure. I'm assuming I have GDB here, right? So GNU GDB. So can we do help here? Yeah, I think I remembered we did this, right? So for help type help, it even said. So this is the help inside of it. Help followed by class. Okay, so aliases, breakpoints, data, examining data files, internals, obscure features, running the program, examining the stack, status inquiry, support, text user interface, trace points, user defined. Let's just put this in there for now, and I'm actually going to quit, and this is where I didn't find quit, you know. So let's do quit, and let's get the normal help of it. I'm just pasting this in the note quickly, and type help all. Right, so let's start it again and do help all, because we want help all. Oh gosh. I hate that kind of thing. I want it all, and then I can scroll. So now we're actually going to copy all of it. Then we can easily search in our notes too later. So it is longer than I expected, but that's nice because it means we have a lot of commands to test. It's kind of long. So this is GDB help all, and we have this horrible line in there too. So there we have a lot of stuff, right? Let's scroll this way. So command class aliases doesn't have anything. Then we have breakpoints, and let's just delete the type. I press C there not to get any more of those. And then we have
Dev Sutar says hello
data.
again, ma'am.
Hello, welcome back. We can also use find, search in memory. So data, I guess. Now we can search in this text. I won't care about all of the things it's starting and stopping strings there. So let's find a function in this, and let's start from the top with this. So Set regular function call history size. Set style function. So style, lot of style. Okay, so I still remember where it was. Edit. Edit specified file or function. This is in the file section here. Okay. The green annoys me a bit. So, list specified function or line. We can load other files into the so L list specified function. Right, so let's actually use this. I'm just typing anything to hop to the end here. Let's do Q. Oh, did we paste it here? And it's going crazy. So let's actually that was really let's get the help while we're at it, right? So GDB H, it had one, and I'm assuming it's the same as help, princess message. So first help on this is this basic one. The others are inside. So now I'm actually going to replace this because it's kinda annoying. And we're going to have to do it. Oh, I did one to money. That's kind of why I did it manually, and then I missed it anyway. So this will make it all green. There's one we want to skip. So these break the nice coloration of this. Yeah. So let's yeah. So redo that one. So let's actually search it from the start here. See if we find any. Yeah, the show is supposed to be there. And the other one was actually set. And it was also this. So I broke this one. It's supposed to be like this. So now we have this nicer. So what's wrong here then? Oh, there. Okay. I noticed these before. So they actually have this character here. That's annoying. Yeah, we won't do this now. It's too many lines. And this bit is okay. I was just going for this bit now. So easy, much easier to read the options. Right. So let's GDB and its options like A. No, I'm messing up. That's the other program. This has what as options? Okay. As arguments of the executable file are passed. We're going to run it. Now we have the basic help, and let's queue this because now we know that queue works. So if we run this again for this, and now we have R2, so we're going to do GDB instead. GDB, what was the name? Func pointer, and we had L. I just think it's named special. Use the file command. Yeah, okay, I get it. I think it was a file, so you might have to save file first. File running. This is when I want to have subheaders underneath here, one level in. The headers of this, and we can make these headers, right? So where's the command class? So Control F, command class file, and we have, or I could have search function. So list specified function or line. So if I type L and the function, I didn't get anything, and it said use the file command. So is there a specific file command then? Use file as program to be debugged, but we already started with the program. Isn't that good enough? So I'm just randomly trying to test this. So it's not a very organized stream. I'm sorry, people. Right, we could fix this one. So I fixed ones that didn't need fixing, and I left other ones. This was obscure functions. I almost have to check it out. Let's actually search again for function, because we're actually looking for information about one function. And let's start this search from the top and search. We have the record function called history frame function. Select and print stack frame by function name. Oh. Yeah, so first of all, we didn't actually test that first thing. Oh gosh, typing in the wrong one. So I was going to do Q, and let's look here again, and let's just make sure that the TryHackMe box doesn't time out. So just recording in my brain the position of this tab here. It's before the three white ones, so let's actually drag these. Come on. We can drag them here just before it. So this one, we have only spent 50 minutes on this only. Oh. So this is why this room should really have more information.
VR Mechatronics says,
VR.
I back.
Hi VR. Because we don't have a lot of information here. So let's if we do func pointer here, and we do special, right? This is a normal function, and also we have a buffer, right? So we need to 1 2 3 4 5 6 7 8 9 10 11 13. I did the same thing yesterday. Don't I know 12 exists? I hear it at once. 11 12 13 14 special, right? Just a test, and we get segmentation fault when we do something that breaks this pointer, which is very reasonable. So 1 2 3 4 5 6 7 8 9 1 2 3 4 should also make a fault, but if we do I'm not going to say the numbers all the time. This should be normal because it's 14 and it adds a null afterwards. So we should do really then later we should do this, and then we should manage to somehow get the address in there. But I was thinking yesterday that maybe we can just send it to it. Because I don't think I can use like escape characters and stuff in here, but we can do it on a normal prompt. Let's just quickly look back through my stuff. So what is this? Top bar. Is it some kind of randomly giving me help here for something? So this is a thing to do, but we don't need to do it now, and this doesn't need to be up. So where did this link come from? It was probably from the... It's a C course that we were sent to by the other page. This one, right? No, this is the rather help. So, I wonder if there's one of these for the GDB one. And let's use this one too. I'm just cleaning up a bit. So, my arm, what happened? So, C programming, I'm assuming this is very basic, right? Getting started, yeah, so I can just close that. Teach your kids how to code. Yeah, we want to do that. Yeah, so this is also very basic stuff. But kids aim. And there are also other languages. I like this. We need to like put this somewhere good. So I don't have a lot of links in that one. So. And this I'm going to actually put here. Maybe here anyway. So it's by the important links. And this we don't need up. And I think this is probably like, yeah. So this is the dude that made this site, the free courses. One of the best courses I've ever done. It's kinda good marks on this, right? This is actual course. I will continue this one after stream. I'm thinking I'll already start it, setting it up. And this is a room. They were actually in our path. We won't forget that one. We can close it. This is another one I found with buffer overflow. So this is just Googled. We can close it. Here we have this official R2 book. This one we'll put the link to the main page. Will that help us there? No? So let's actually copy a bit of the URL there, because we were still reading here too. And let's put this in our did I close it? I did. So let's keep it up. And this is like a manual. And we can close this down. If we were not reading, we're reading. We don't need the URL to it, do we? Well, it kind of fits. So this is like basic info to start there. And this is what we're actually doing. And this was a great link. I don't know if I have like general resources, do I? Links general. No, I don't have any general links. Who would think that? So this one is kind of cool too. It can fit there. So if you didn't know anything about cybersecurity, you could just read this and know a lot, right? And also we have the GDP information here, so we'll want to keep this one up. Oh, this was my phone pop up, this author, and I was like, why did Google Books or whatever it was pop this one up? So I got curious what it was. This is a responsive design thing. Okay, and this was actually all I needed. Don't need to do a course on something when you can just see a list of the commands, right? So all of these are the same. That's the relative stuff. Well, I've never done anything on this page. I can look at that later. Then we go into do this, install another day. So I have Raspberry Pis over here. So we'll just install this one, meaning D-Shield, which is a honeypot. So I have another one too. So we'll probably do 2, just to test stuff, you know. Need to test stuff. These links we can keep up for now. We can close this, and this is that link. So let's put this one in our notes on ASM. I didn't close it. So this is something to do. And what's this? Now we can close that. ASM tutorials. Get started. Lessons. We can look at this, but not right now. So here's honeypot information. So didn't I just close this? I was opening Google, you know, search hits. So yeah, so several explanation in different ways is always nice. Reducer has a visual explanation of the system call process. Okay, sure. Yeah, I like pretty images, and then there's a nice background color. Let's put that in the list. And then we have a YouTube video. Oh, so there were several YouTube videos. I just clicked the links, I don't know. And this is John Hammond. We'll have to put that one in the list, right? So I'll do some remembering and researching. So I have no idea what this is. But if I put it in my links in my browser, it will just disappear in a lot of stuff. So I am hopefully done soon. But this is important to, you know, if you find, no, this was probably just Google, you know. But if you find good resources. So why am I on this page? Assembly intro. GitHub about code. Let's close it. I don't know what it is. If it popped up with the assembly thing Google we did the other day. Alright, this was from one of the assembly. I started looking at this one, I think. Yeah, and there's his name. Okay, right, it's connected now. He had this tutorial there. So we already saved one. He had these boxes. Videos on them. On his YouTube. So it kinda looks nice. It looks nice, but let's actually save the link for now and in another way. So this is people suggesting things. So we're kind of like at 0 here. I already put this one over here. I created an account. I think I might have had one, but it's probably gone. Someone suggested that yesterday, I think, right? Right, I found a nice list here. It's already in my links here. So we can close this. So you got to help me clean my tabs out. Short guide. Yeah, we like short guides, right? But let's put it over these. That's a short guide. It can be first. So if we do short guide first. And this one looked good. So I'm leaving that second. These were like exercises, right? So lessons, exercises. Here's a Google. ChatGPT. Right, so ChatGPT is for this room. Someone told me about this app, so I will look at it later. I still haven't done. And then we're at Pilot Other Things. So I think we're at something different here. Yeah, and then we're at debugging VM. Right. And debugging VM too. But I got theirs to work. But mine didn't. I feel I'm a very bad streamer right now, just cleaning my stuff out here. So I can close this. It's just me moving my streams over to YouTube. And here we are at the immunity debugger. So this is actually tabs that are related to, and then I just had some, like I done a lot with VMI earlier, so it's interesting to connect old stuff to good new stuff, right? Yeah, and here we have the tip of this honeypot there, but the URL is right. So, and I need to sort this. So let's get back to this page. Now we only have one page. We don't have a million ones. Well, I guess it's still more than 2 pages. So less risk the stream will crash. This is why I kind of prioritize this, right? Also, for a break, we needed a break there. I needed a break. We could do this and read this through and add notes on GDB that we kind of started, right? So we started making GDB notes there. So the basic commands for GDB. The most basic one is run, of course. So run. Let's do one of these. No, it can't, right? That's so annoying. So I don't really use this character for anything. No, it can't. You can't even... Some characters you can't even put in these afterwards. Right? So run or R. And this will run it. Runs the program, right? So let's just do this so we have it all done. And I'm typing in the notes. So today is not my best day. I can feel my throat is bad again. Yeah, I hopped over there, right? So we don't have anything loaded or anything now. So Q for quit. So I'm just adding. I Okay. And then we have quit or Q. Quit GDB. And then we have something else that we don't know yet. So GDB F, and we can run it from here. So if we do R, just to test the new ones, and it will starting program. Now it's waiting for the input. So if we do, this will give us the error. Segmentation fault. So if it R again, it will say, do you want to restart? Yes, we want to restart it. And then we get the input again. Exit it normally. Right? So Q is Q. When we start it, we have a fresh one. If we want to put one of the breakpoints, let's hop over to the web page and let's continue reading here. B break vuln b vuln is for the function. So if we do B and main, if we do B main, we will add a breakpoint there. So if we now run it, it will not run more than a bit. And then I think it was next. Let's assume N, single stepping until exit from function main. Has no line number information. And this is the input of the program. This is a normal function. And it should have exited now. It should have finished the program. Right, let's add this to the notes. So, I think it was break. Break, yeah. Or B. Add break point and function name. And I'm assuming this is required, right? So let's do those. So it should be at the start of the function name, right? That's what I was thinking. Are the other things like, I mean, the variables definitions are the first lines in the main function. Will they be already done? I think I got funny stuff there. So next or N step. Well, exactly what did it say? Single stepping until exit from function main. Yeah, I need to know more about the next. We'll have to next. Running. Command plus running. This here we have the stuff. We found the stuff. So instead of doing run and a breakpoint, we can just do start, and it will stop at the start of the main function. The person who made this thingy didn't know this, right? Or did they? And was trying to teach us general stuff. Oh, this is the good stuff, and it's kind of far down, and it's not a lot. So let's actually copy this bit and put it first. Even first, you know, on top of everything. So, and let's actually we can keep it like this. Advance. Continue the program up to given location. Same form as args for break command. Attach the process. Continue FTC. Continue program being debugged after signal breakpoint. Okay, so if we do C here now. Oh, sorry. I'm editing my notes. There. So if we do C now, we should exit normally, right? Yeah. So continue or C. Continue normal execution, right? And what does this say about step? Step until it reaches a different source line. So step 1 line. Step 1 instruction exactly. Yeah, this is kind of what I wanted before. Because I thought it was odd that if you do one step from starting the main function, you should be in the declarations, you know, not getting input at once. It's too early. So that's why, because step is not actually one step, it is more. So we're actually looking for the functions here, right? But we're actually really just learning random stuff. Advance, attach, continue, detach, detach checkpoint, detach, disconnect from a target. Then execute on the selected stack frame returns. Oh, okay, so until the end of a function. But what have we selected really? How to handle signals. Inferior. Use the commands to switch between inferiors. I'm like, what's an inferior? Interrupt the execution of the debug program. Jump. Continue program to be debugged. Add a specific line or address. So jump. Let's see what happens if we do jump, right? So if we do R for run now, and we're at the breakpoint, and now we do J for jump, and it requires an argument which is a starting address. So how do I list these addresses? That's what we want to see. So first of all, oh my god. So I double clicked it. I want one word selected. I don't want a million words selected. RJ. jump to address. So today I remembered the 2Ds, but I missed an R there. I was just typing too quickly, I guess. Kill execution of program being debugged. Kill inferiors. Next. Step program proceeding through subroutine calls. We have next already. Next step 1 instruction. Yeah, so next we want this one in the list. So next or NI. Step exactly 1 instruction. And this makes me think, what's next then, you know? Proceeding through subroutine calls. Proceeding through subroutine calls. What about... And through, with through, does it mean that it goes through to them, or that it pauses them and just assumes they're one line? So like step into it, or what? Or just over it? Doesn't say good enough for me. Queue signal. Queue a signal to be delivered to the current thread when it is resumed. Reverse continue. RC. Continue from being debugged but run it in reverse. Oh my god, that's cool. We can run it in reverse. Reverse finish. Execute backward until just before selected stack frame is called. And that's called reverse finish. Reverse next. Step program backward. Proceeding through subroutine calls. And then the next one instruction. Oh, this is cool. So cool reverse instructions, reverse commands. So I'm not going to add them all to the list. So reverse step program backwards until it reaches the beginning of another source line. And we will have step here too. Run. Signal. Start I. Start is defined for stopping at the first instruction. So start I is when we want to go step by step from the start. Toss. Apply command to all threads, ignoring errors and empty output. Connect to target machine or process target core, target CTF, target exec, target extended remote, native process, target record B trace, collect flow, control flow trace and provide the execution history. Target record core, log program while executing and replay execution from log. Log program while executing. Target remote, use a remote computer with serial line using a GDB specific protocol. Target T file. Use a trace file as a target task. Switch between other tasks. Task apply command to a list of tasks. Task apply all. What's tasks? Apply command to all frames of all threads. Apply thread. Apply command to a list of threads. Thread. Apply all. Thread find. Thread name. Yeah, so we're not doing a lot of thread stuff, right? It's just very simple. There's nothing like function, give me this memory. It's not in there. It's in another bit of it. So if we're looking at this, it's not obvious. So maybe the stack bit, examining the stack. But also, what about the rest of the memory? I'm like, where is it? It's about breakpoints. We can do lots of stuff. Oh. I'm like, remove a breakpoint. We need to be able to do that, right? Disable, delete breakpoints, delete all breakpoints. Delete del D, delete all of some breakpoints. We can clear breakpoints at selected location. There are stuff here. Data. So, a lot of dumb stuff here. That sounds promising. I think I need to like move a bit. I'll go check on my kids again. I'll be right back. Oh. So, checked my kids and got some tea. Because my throat is still sore. I don't know why. I usually never do that now when I'm streaming this like this, you know? So, I just brought my... So these are great, but when I ordered them last time, there were only white ones. I ordered 3 of them, and I got nothing. They were very cheap. And one pair, I had 2 pairs, the black ones. One pair is like stopped working, falling to the floor too many times. That's left there. So we have some Roribo vanilla tea. So it's just like that, with some honey and milk in it. So, and I feel like I'm on a slow speed today because this is like a lot of new stuff. So I guess it's not really that slow. I guess I'm talking more than usual, right? Because I'm talking constantly. So if we were doing a box, I would be like thinking too, doing things. Would I? Am I ever quiet? So maybe I should have warmed the water more. But I wanted to be able to drink it at once. Dump memory. To a raw binary file. So let's do dump memory, right? What on earth was J? Alright, jump to something. So we just started it, and there's a breakpoint, and this means that the functions should be in there. So if we do dump memory, Linus, what do you do? Hello. Okay. So he doesn't want to be on stream, so he didn't answer. Yeah, I thought so. So we need a file name. Test. Well, let's do m dot. Let's do m. Missing start address. So I just want to all memory of the program. So in this, it doesn't say much more than dump memory, you know. So let's go up to where it says how to do help. I cut that away. That's smart, right? There are different kind of files here. I just want the memory to file. Find, search memory for sequence of bytes. So what will be the response if we do find? Find So I'm just trying to remember the code. Wrong machine to tab on. So this is we can do special. It's in there in the text too. Why I clicked here? So require argument required. So help find. There we go. So this is annoying because we don't know anything about the memory yet, but we'll have to find things. A line number or address. Line numbers are key too. I'm thinking if you do dump memory, don't you want all the memory, right? So help dump memory. Oh, I'm getting annoyed at. I did click, didn't I click? Help. So it's because of the VM, you know. Sometimes I have to click twice. Memory. Dump memory. Write counts of memory to a raw binary file. Arguments are file, start, stop. Yeah, but I want all, not start and stop. And also I don't know what memory we're using. Mem. Define attributes for memory region and reset memory region handling. Memtag output. Printf. Set a little set. Oh my. Yeah, so I'm thinking it's time to get a smarter help than this. So many sets. Set style. Undisplay. What is? With. So this is like a full programming language. Right? Yes, I have to stop talking so much. My throat is not nice. Maintenance. So let's go to ChatGPT and ask it stuff instead, and let's make a new one. GDB. Linux. How to list all memory contents used by app. run. We can pass arguments. Info proc mappings. So, who would have guessed that? Not me. Yeah, but for dumping it we need the address. Info. That was it. So I'm not sad, I read a lot of that, it was nice. But at the same time, it's kind of nice that we have ChatGPT now, right? So when I felt like, nah, I wanna get the answer, and I don't have a human to ask. We can ChatGPT it. So dump memory. I did do the help here, help dump memory. File start stop. So file is M. Start is so if you copy this, so now we should get this first bit of it. Nothing. So 6 to 6. Oh, sorry, I overwrote it. Well, I guess that we will use another one, right? Wrong IP. Because the new one is okay. 181, I remembered. User 1 password. So and then we do we have like hex edit? So this is the memory. So in this bit of memory we have these two. The special function is in here because this is its string there. And this is the kind of thing you don't want in your so yeah, my kid's making pizza. When I went there and asked him, should we do this for dinner? He was like, oh, I already started making pizza. Just getting my tea bag out of the tea. So, let's instead ask how to show the memory, right? I think we did this. Am I blind? No, I'm in the right place. You can use to display. Yeah, so it already had the command there. Oh, he's coughing. Yeah, so I'm kind of thinking that I might be getting a bit sick because my throat really hurts. And now my kid is coughing. Maybe he just ate too much. I don't want to get sick. Yeah, right. And also my hubby, he said that, oh yeah, so everybody from work, there's no one there. Oh well, one guy is coming, but his whole family is sick. So I won't be extremely surprised if I were to get a bit sick too. Actually, right, let's do help on this. X FMT address. Address and expression the memory address to examine. FMT is the repeat count allowed by formal letter and letter size. The formal letters are X. We want X. The size letters are byte. We have BX. So X/ is the command. And then we have 64BX. What if we just do this with... Didn't try it? So I have to just... There. So my stream control phone keeps complaining about not being able to charge. So then I'll just... It happens once a month. I disconnect it and connect it back. It doesn't have any battery really anymore. Reuse your old tech, right? So 0x or 0x, of course. So 400,000. So, but I want to see more, right? So what if I do now? Let's do an odd number, right? Yeah, it does any number. Well, this is not a lot. So, what other format could it do? I'm sorry, but I have to do binary. No? Oh, I replaced the wrong letter. Now we have binary. I like it. Why so much space? I would prefer to have it formatted differently. So, yeah, I can't change the size without going to the menu, I think. Let's look. Control plus and minus. Okay. Right, so let's try this one. Now, that's looking better. And just for fun, let's do decimal too. So replacing the B to the D. And again, I changed one letter because I was thinking B should probably be binary, but it was a T. So we have the values in decimal, which is, I guess, the most human readable, right? I mean, it's what we're used to. It's a minus there. Binary is better because that makes it odd. So if we do the binary in this resolution, yeah. But this looks pretty. I was thinking, why couldn't we do it? It's just overflowed out of the page. So, what if we do like 1,000 now? And we get this horrible message. Can't it please just type? We have buffers nowadays. We don't need this. We can see, we can scroll. So we don't want 1,000. It's a bit much. Yeah. This was not useful. So my whole this is such a horrible thing to me. I just want the output. I don't want a lot of mess in there. So let's actually run the help command again. Why not, you know? We don't have to scroll up so far. T is a binary. But what do we have? So what about S? Well, this is kind of interesting because now it actually does it as strings. This is a special function. So we have about the place, right? Oops. Yes, I think when we used whatever we did yesterday, we got a better one. I'll just check the notes. So we did a lot of messy stuff then too. Is this the right one? Oh, I know what this says. This was when I tested the Pico CDF. So this is the THM room, meaning this one. So, and here's the code for the first one. Yeah, right, I remember. I was like, what should I do? Func pointer, here's a func pointer one. So, this is the very start of the function. But I'm assuming this will be put in another place in memory anyway. Now we're testing GDP. So this is what it suggested us to do, the ChatGPT. And then it said, so I'm going for the function one here now. We added the break to main, we tested the stuff. Info frame. Yeah, so something info maybe. Info frame. And we got all the registers. Oh, info functions, we got this. Yeah. So we need to add these to the notes. So info frame, get register, info functions, get function, info, right? So that's why I was searching here for function and I didn't find it. So what if we search for info? I'm going backwards. Not helpful, so info. Just general info. So it just took it this long to get the formatting done down here. So info. So this didn't do anything at all. It's time to do info function. And we still have this problem. I need to know how to get rid of it. Can I ever? Will I have to live with that forever? Here's a special one. Yeah, so I feel like not talking a lot, so let's look at this again. Yeah, I was assuming from what we saw there that we can make scripts for this. So you can oh gosh. No, my throat hurts. Sorry. Let's go this here. So how do I when running a program when in GDB and it requests
Lab Monkey says I put you on mute, you talk so much.
Sorry. Yeah, I talk too much and my throat hurts. So, but I feel like people who have streams that when they don't talk, I feel like, why are you streaming if you're not talking? I want them to tell me what they're doing all the time, you know. I'll try to be quiet a bit because of my throat, so. My god. I could probably answer this myself when I think about it.
Lab Monkey says this is ASMR hacking. Deep contemplation over the sound of a mechanical keyboard smile.
Okay. Oh, I don't like it myself. I don't like it. I want people to talk. So I make my streams the way I want to see them, you know. But now my throat hurts, so. I'm not even reading this. This is when it's bad. Well, I kinda know the answer, right? It's just that it's messy to convert, so I'm thinking I gave it the right one to test with. So every second I'm not talking, I feel like I'm a bad streamer, you know? Because that's what I would think. So instead of me reading, let's TTS it.
When dealing with a buffer overflow exploit, especially in the context of a program running under GDB that requests input, you need to carefully craft the input to achieve your goal. In this case, you need to provide 14 characters followed by the address, converted to little endian format. Here's how you can do this. Prepare the exploit string. 14 characters of padding, you can use any 14 characters for the padding. Let's use A for simplicity. Address to overflow with the address 0x0004000567 in little endian format. Little endian means that the least significant byte comes first.
It does.
To convert 0x0004000567 to little endian. Make file. Original 0x0000000000400567.
Can I do this in my
Little
input?
endian.
I don't think
6705400000000000. We will represent this as a series of bytes. Create the input string. Combining the padding and the little endian address, the input string should look like this in hex. 41 41 41 41 41 41 41 41 41 41 41 41 41 41 67 05 40 0 0 0 0 0 0 0 0 0 0. In ASCII. Arduino. AAA \x67 \x05 \x40 \x00 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 \x00. Input the exploit string in GDB. When your program pauses and asks for input, you can provide this string. Here's a detailed step-by-step. Start GDB. sh. gdb/your_application. Run your application. sh. gdb, run. When the application pauses for input, provide the crafted string. In GDB, you can use Python to input the string directly. sh. gdb, Python print, *14 plus \x67 \x05 \x40 \x00 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 Copy the output from the Python command and paste it as input to your program. Alternatively, you can use the call function to directly input the crafted string into the program.
I'm not sure this works. I think I tried before, you know, but let's just try. I think this will just be characters, you know, when you do normal C input, all of these will be characters. We're not at the prompt, so we can't type anything. As we're not at the prompt. How could we use a command? Misspelled. You need to preload the input in a way. Yeah. They're putting it in a text. This is not good. Okay, so you can do this. Okay, we'll try this. And we'll copy this. But I'm curious why it keeps calling text files text. Oh. All right. Yeah. So we did it, meaning this was the correct way to give it the address there. The question is, how do we do this in a more simple way? Because I'm not pleased with this. It's not good enough. I want to do it without having to run any program if possible. So I just stopped it now. So let's, if we were to just run the program, is it like F it started with? Yeah. And we can just do the same thing, input. And it still works. But I'm thinking that this might move, you know. And it might not be in the same place. So if we were to start GDB here again, just randomly, you didn't even start it with it. So there, and then we run it here. So I'm not lazy, I'm efficient, right? So if we do this in the other one, it still works. Is it because it's relative? So because that would be a very odd non-relative address, right? So it smells like a dog. Like a wet dog. What is that? It's my kid pizza. I don't think I want that pizza, right? It must be that. Yeah. Yeah, it annoys me actually, the smell. So I have a bit of skin that's annoying. Get some pliers in there. Oh. Oh, yeah, it's still warm here. It's 29 Celsius now. Yeah, so what I was also thinking, we don't have to create a file, right? We can just do... So this is what I was thinking before, but I was thinking that we would have to change the address every time. And then this wouldn't work. To do this, to... And when I say before, I mean yesterday. If it's always the same, because it's in the relative bit of memory that this program uses. I know a little about this. So this didn't work. So... So, I just... Why? Did I like misspell it or anything? Or do something else odd? So... Yeah. Okie dokie. So we need to pipe it, and I overwrote the whole thing instead. That's of course what I did. We'll fix that. So first of all, let's save this. And that was a bit annoying that I did that, but that's what happens. It was just because it was the other direction first, you know. Overwriting the files. So I need to play with it more before I'm done. This is the best test, really. Is it the same when we totally disconnect and restart, right? But I need to copy this to the notes. So where did I put the notes? Right, you can hop over here too. Where is this file? It's over here. And let's do this, and let's actually remove this because I was stupid. So I don't do it by mistake, because I was like, right, okay. Yeah, you should think before you do things, not just type random stuff. I think we can like delete the rest of it because it's kind of useless. And it might be confusing. Since I changed this. So I'm actually going to go... Well, I guess I should do Control L as someone said. And we have a new IP. So user 1 password. CDO tab 2 and notes, copy. So it was because I copied too much. I copied one character too much, so that's why I did that. So it's still the same, meaning it must be a relative memory address, right? So let's see if we can get some more information about this from ChatGPT, since I'm too tired to Google now. So I did this. How come this works? Does it always use relative addresses? Ah, yeah, I know what that works. But the pipe, none of the things. Yeah, in many cases, especially for simple buffer overflow exploits, absolute addresses are used. The address is an absolute address. Okay, and whether this works, relative percent of several factors, including the memory later for the person and the address space randomization is enabled. Yeah, so, but I started it twice. I started the program twice in different SSH sessions just to test. I also restarted the computer. To me, it seems weird that I don't care about spelling. That I get the same absolute address again. Let's see what it said here. Consideration: address space layer randomization is a security feature randomizes memory address used by a program, making it difficult to predict. It might not be the same every time you run the command, which could make your exploit unreliable. You can check if it's enabled. Sure. So zero bit means disabled. Conservative full randomization. Ensure that the environment, it still smells like wet dog. I do have the window open though, so it might be outside. I'll just check. It's annoying. No. Though I can hear it on the plane. So, well, let's see. Ensure that the environment, the layout memory segment is consistent between runs. Differences in variables, command line variables, factors can affect memory layout. Program compilation, the way the program is compiled. Example of disabling. Yeah. Yeah, so I want to make it not work. That's my goal now. Can we make it not work? We're not anything but user on this one. So target is static and known might not always be the case. Real world, yeah. The consistency of the address across different runs and even after reboot may be explained by several factors. Yeah, so we already confirmed that this is 0. Executable segment. The base address of an executable might be fixed in certain conditions, such as position independent executable is enabled. Non-apply executables of fixed base addresses, and the function will have consistent addresses. So, I'll just go check this way too. No, maybe it's just my nose being odd. I think I'm getting a cold. Oh. Yeah, I thought so. It might not exist and didn't. So the base address of the executable is fixed. How fixed? I mean, if this is a relative address, I mean, you can't just say that this executable will always be on this address. There might be something else there, you know. I don't... annoying. If anyone has knowledge of this, you're welcome to teach me stuff. So we will go into this room because the other one was not explained a lot. And this one isn't better, of course. It's It didn't say anything here. Let's just try and get buffer overflow by, and the hint was check the memory address of the function, which is obvious. It's the how, right? We didn't get anything, and not a hint on what to do at all. Nothing. The previous one was do a text buffer overflow, right? And that's kind of logical. We just write too much, right? Too many characters. And we didn't get anything here either. This annoys me when rooms are bad. This is bad. Very bad. So it's assuming it's enabled. Yeah, so it's almost 17 and my throat is no good. But at the same time I will continue digging at this. Maybe I should just continue streaming but not talk as much. Though I haven't been talking much now lately. So I'm also thinking we want to do the R2 one, but we also want to just continue this. Well, let's look at the next one. Maybe it will actually give us more information. So I will use the TDS now since my voice, you know.
For this example, look at Overflow 3 folder. Inside this folder, you'll find the following C code. This example will cover some of the more interesting and useful things you can do with a buffer overflow. In the previous examples, we've seen that when a program takes user's controlled input, it may not check the length, and thus a malicious user could overwrite values and actually change variables. In this example, in the copy_arg function we can see that the strcpy function is copying input from a string, which is argv1, which is a command line argument, to a buffer of length 140 bytes. With the nature of strcpy, it does not check the length of the data being input, so here it's also possible to overflow the buffer. We can do something more malicious here. Let's take a look at what the stack will look like for the copy_arg function. This stack excludes the stack frame for the strcpy function. Earlier, we saw that when a function, in this case main, calls another function, in this case copy_args, it needs to add the return address on the stack, so the cali function, copy_args, knows where to transfer control to once it has finished executing. From the stack above, we know that data will be copied upwards from buffer 0 to buffer 140. Since we can overflow the buffer, it also follows that we can overflow the return address with our own value. We can control where the function returns and change the flow of execution of a program. Very cool, right? Know that we can control the flow of execution by directing the return address to some memory address. How do we actually do something useful with this?
Never seen this.
This is where shellcode comes in. Shellcode quite literally is code that will open up a shell. More specifically, it is binary instructions that can be executed. Since shellcode is just machine code, in the form of binary instructions, you can usually start by writing a C program to do what you want, compile it into assembly and extract the hex characters. Alternatively, it would involve writing your own assembly. For now we'll use the shellcode that opens up a basic shell. \x48 \xb9 \x2f \x62 \x69 \x6e \x2f \x73 \x68 \x11 \x48 \xc1 \xe1 \x08 \x48 \xc1 \xe9 \x08 \x51 \x48 \x8d \x3c \x24 \x48 \x31 \xd2 xb0 \x3b \x0f \x05. So why don't we looking at actually executing this shellcode?
Yeah, so I'm not in perfect shape. I'm thinking, should we raid this person? It's actually doing like job hunting. It says job hunt like a hacker. and he's in talk shows and podcast category. So I've never seen him before. So I don't know a thing, but it's the only one in the InfoSec streamers. And it's not like I have a other great alternative. So why not? I'll just prepare. I'm sorry for all the short stream, all the stream end here. Why can't I type? I can't type with my keyboard. Yeah? It's just a dash. Oh no, it skipped. It hopped to another keyboard. No, we have the right keyboard. This is extremely odd. Oh, okay, I got it. It's just that it made a new line, and it's just the chat that's odd. It's actually there, the character. So when I was typing here, I did a dash, and it's no dash because it's hopped up. There's no space or anything. Extremely odd. It was like, is my keyboard broken? But then when I click dot, so I did, then it's on the same line. So now we have a dash there and a space. And let's do a raid. And my throat is like out, so, and also I'm tired, so I don't feel I'm very useful anymore. I'll probably continue anyway with something, or maybe I'll just take a break and be with my kids. We'll see. So I don't know how many people. It's just one person here now. Yeah, this is a boring stream. So, yeah, I wasn't even watching myself. So wherever you are, and I don't know about YouTube if someone's there. This was an odd, strange stream, so. Thank you, everybody. Bye-bye. And I'll hope to have a better throat tomorrow. I really feel like, yeah, this is not normally what I sound like. If I relax my voice now, I sound like this. If I try to talk about it, now I sound like this. Bye-bye.
Go down here too. All right.